This is the recording for post-lab 1 for the measuring and metric system lab and for the density lab. And the purpose of the post-labs is that you need to make sure that you did the lab properly so that you can answer these post-lab questions here, and it's testing you that you did the labs correctly. So I'm repeating certain things that you encountered in the lab, such as certain calculations that you definitely came across. So you have to make sure during the lab that you were able to do these so you can do them now. So this is the test for doing the lab correctly. The first question is simply that you attended, respectively if you do the labs at home, that you completed everything about the lab experiment and of course submitted the lab report with the conclusion, which you also do when you do the lab intensive. All right. Question 2 is the motivation. So you find that in the lab manual, and this very first one about the metric system and measuring, that's a prep lab for the others so that you come across measuring itself. And if I try to click on this one here and actually get it, there we go. So here, the measuring part, units in the metric system, significant figures, equation, computations, so that you're prepared for the other labs, especially measuring in the metric system and becoming familiar with significant figures. It's pretty much the only motivation that I have for this particular lab. You will see that other labs have different ones that connect to real life as well. Okay, the second question here is you pretty much just have to type in some of your own data. And so I'm not going to type anything in because you got your own data. As long as they're reasonable, you will get full points. Notice that this particular one gives you 4 points. When you first submit it, you might see that, oh, why did I get a 0 on this one here? Because Blackboard is trying to grade it right away, and I need to go in there manually, which might take me a day, and fix it. So if you see at some point a 0 right after you submitted it, do not worry about it. I will fix that. All right, ruler dropped. So that's the one where you drop the ruler and then you caught it. And here I'm saying, okay, let's say that you drop it for 13 centimeters before you catch it. That's about 5 inches. What is your reaction time? So compute your reaction time to 2 significant figures. If you come up with 5.7 seconds, you probably did something wrong in your calculation. If you come up with 0.00004 seconds, you also probably did something wrong. It's a fraction of a second, but somewhere around 0.1 or 0.2 seconds. All right, errors in this experiment. Well, you used a certain number of measuring devices, such as the caliper, the measuring tape, meter stick, you paced, you measured the mass, you tiered the scale, digital balance, or spring scale. I'm not sure why I checked measuring time for this one. Oh yeah, of course, it's the metric system lab. Yeah, of course you measure time for these, but so these 4 apply, the others do not for possible errors. R and S stand for random errors, which you always will have. You can just minimize them. And S stands for systematic errors, which, if possible, you should get rid of. All right, in the conclusion, usually the conclusion has 5 parts. You will see that in the post lab. This particular one really only has 2. This one is already in the correct order on the left-hand side, and you have to match it up with what you have on the right-hand side. So the first one is list your results or examples of your results. You don't have to list all of them. I actually did a little bit of an overkill here. And then you have an error analysis, this one here. As I said, the others are a little bit more elaborate. I know this is very long here. It looks like it. You don't have to write that much. And by the way, for the metric system, you're not writing anything anyway. That's why I give it to you as an example. But it has to be concise, and it has to cover the certain points, such as list some of the results, assess those results, compare them, and write down an error analysis for that. That's usually the way it is. The very first one is just a little bit off. Just these 2 here. List the results and the error analysis. And usually the error analysis is just qualitative. That means that you really don't have to compute the errors at all. There's one exception, which is the very next lab, the density lab. Okay, so let's go down here. So Oh, one last question, I think, for the measuring and metric system, or a couple more, I think. So after you complete the lab, evaluate the photos and descriptions here. So assess the statement. This measurement should be recorded as either 3.1 centimeters or a little more than 3.1 centimeters, but less than 3.2. And you see here in the edges there between 3.1 and 3.2. So that statement is correct. All right, says the next statement. The vernier caliper reads exactly 31.1 millimeters, which is 3.1 centimeters. Well, let's see what happened. So the 0 is between 31 and 32 millimeters, but it's closer to the 32. So that already then disqualifies that there could be a 0.1 there. And then we're going to see which one of these lines up. This is what you should have gotten out of the lab to see how to read a caliper. And it looks like the 7 lines up the best. Notice the 6 is a little bit off, the 8 is a little bit off. If you don't see it in this recording, look at the actual photo in your post lab. So this one is actually 31.7 millimeters, which means that this statement is incorrect. The spring scale is used in a vertical position to measure the mass of a specimen. Assess the spin. The spring scale is calibrated correctly. So on the right-hand side, it measures something. There's a mass hanging on it right there. And on the left-hand side, it's being tiered in the vertical, and there is this little slider here, which is definitely not on the 0. So this one is tiered incorrectly. It would give a systematic, in fact, a relatively large systematic error. So this statement that the spring scale is calibrated correctly is incorrect. Okay, and then this one here, an upcoming lab on the pendulum, the following times are stopped on digital watch. You did the pendulum, or you will do the pendulum lab if you're in the at-home lab. If you did the lab intensive, you have done the pendulum already. So either way, there's a pendulum, you let it swing 20 times, and you measure a total time of 49.07 seconds. Okay, then you make the pendulum a little longer, and again, you let it swing 20 times. Obviously, since it's longer, it has to swing a little bit more, so 53.20 seconds. And you make it a little longer, 56.55 seconds. And you make it a little longer. Always 20 swings, forth and back. So it swings a little bit longer, 59.81 seconds. And then it says this statement here that the last one shows, as you make it yet a little bit longer, it reads 103.07 seconds. So comment on that one. Respectively, right here, say if the statement is correct or false. On the following up question here, you will actually comment on the false ones and try to explain why they're false. All right, density lab, the motivation for that one. There are 3 of them. So we look at the lab manual for these. They are in the front of the lab manual. So important properties with which different materials are distinguished from each other is their density. One of them, there's Archimedes principle, which is the underlying principle of why, how in boats and hot air balloons float. And then there's a little bit more here on significant figures, measurement errors, how errors propagate. This is the only lab that you will actually quantify what the errors are, so you will actually compute them. For all other labs, you will not do that. You have not done it. It's just this one. Oops, and I guess I should, whenever I click on a statement, it clicks on that box there too. So here you have to calculate the density of a specimen. It's a regular specimen, regular shaped specimen with height, length, and width. So you multiply these 3 here, and of course you have your own numbers in your post lab. You come up with a volume, and then you divide it into mass, and then you come up with the density for it. 3 sig fig, correct units are grams per cubic centimeter. This one here is the specific gravity part. So you used one of two methods. You used either the immersed mass method or the effective mass method, and you have to do something here with the original mass of the specimen of 53 grams and either 35 grams or 18 grams. And again, you have your own data and figure out what the density is. The specific gravity equation comes up with a number without units. Just attach the units and you get the density for that. Specific gravity and density are the same numbers, just one with units, the other one without. And the reason they're the same numbers is because they're based all on water, which by definition has a density of 1.00 grams per cubic centimeter. And this is possibly the last one on this post lab. So the errors for the density lab, there should be 5 of them. Let's see here. We didn't measure mass in this particular one. That's why I got confused earlier. Not tearing the digital scale, that makes sense. The wet string and water left on specimen, and so on. Not aligning the caliper 0 correctly. Measure mass. And measuring dimensions with a caliper or measuring tape. So these are all the possible errors for the Nancy lab. And it should be a very accurate, it should yield very accurate results because there are no moving parts and you can measure very accurately with a digital scale and with a caliper. And that is the recording for post lab 1.